Hello friends, myself Assistant Professor Partha Mistry from Mahatma Gandhi Institute of Technical Education and Research Center Navsari. Today we discuss about technical topic that is superposition theorem of our subject that is electrical circuit analysis. Our first chapter is about network theorems. So there are many more theorems: superposition theorem, Thevenin theorem, Norton theorem, maximum power transfer theorem, reciprocity theorem. So apart from that, today we discuss our first theorem, that is superposition theorem. Here is the flow of content. First of all, we discuss about the statement of superposition theorem, then the condition for application of superposition theorem, and after that we are going to the practical example which will be asked in GTU exam. We have discussed today the two examples of superposition theorem. So friends, let us start with the statement of superposition theorem. So friends, here is the statement of superposition theorem. The statement suggested that the response in any element of a linear bilateral network containing more than one independent source can be obtained as the algebraic sum of the response obtained by each independent source acting separately at a time and with all other independent sources set equal to 0. So friends, this is the statement of superposition theorem. In entire electrical network which contain either linear either bilateral network containing more than one independent source can be obtained as the algebraic sum of the response obtained by each independent source acting separately. So friends, what happened in the superposition theorem? This theorem is applicable only to the independent source. This theorem is not applicable to dependent source. So this theorem is only applicable to independent source while the another source are set equal to 0. So while evaluating the response from the independent source, other source cannot be removed bodily from the circuit. Instead, you suppress all other independent source by setting their values to 0. Suppose one independent source we have considered, suppose voltage source or current source, but that must be independent. So at the same time, if other than that the source is available, the value of that source must set equal to 0. So how their value becomes 0? So in next slide we see that. So the suppressed source then behave like the following replacement. Ideal independent voltage source is short circuited and ideal independent current source is open circuited. Suppose you consider one independent source and remaining sources are either current or either voltage. So if the remaining sources are voltage source, then it will be short circuited at the same time, and if the current source is given, then it will be open circuited. In some case both sources are given, so according to the this criteria, the voltage source is shorted and current source is open circuited. The superposition theorem is applied to determine current and voltages which are linearly related to these sources acting in the network. Let us see one example of superposition theorem. Determine the value of I1 in the network of following figure using superposition theorem. Friends, this question is asked in GTU summer 2019 for the 7 marks. So it is important to discuss this example with you. So friends, let's start how this example will be solved. So friends, we have to find the value of I1, which is flowing from the 2 ohm resistor, and the response of I1 through 30 volt and 3 ampere we have to discuss using superposition theorem. So there is a two case over here. because two dependent source we have. One is 30 volt and another one is 3 ampere. But one dependent source is given, that is 8i1. So friends, we have to just focus on independent source, not on the dependent source. We have to just make into calculation for the dependent source. We have to not either open or short the dependent source. We have just make in calculation the dependent source. We have to just focus on independent source, that is 30 volt and 3 ampere. So friends, this all about the configuration of this example. In first case, we consider the 30 volt source. So friends, in this case, we consider the 30 volt source alone, and the response of 2 ohm resistor we consider in this case, that is I1 dash. So if we consider the 30 volt source alone, so as per the superposition theorem criteria, if the remaining sources are current source, then it will be open circuited, and if the remaining sources are voltage source, then it will be short circuited, but it must be independent. So in this diagram, the current source is given, that is independent. So whenever we consider the 30 volt source, the remaining sources are set to its zero value. So the current source over here is open circuited as per the superposition criteria, and the response from 2 ohm resistor we have to find out. So for the 30 volt source, for the case 1, we just consider the I1 dash current flowing through the 2 ohm resistor, and our goal is to find out the value of I1 dash. Okay, so friends, it is easy to find out the I1 dash. But how we find the I1 dash? We have calculate the current flowing from each and every element. So we can clearly see that over here 4 ohm and 2 ohm are in series, and I1 dash current will be flow from the both the resistor. But what about 6 ohm? So we have to find out the value of current which flow from the 6 ohm, and finally we get the Kirchhoff voltage law equation of this particular loop. So from the figure we can clearly see that the 8I1 dash will be flow from the downwards to this direction, and I1 dash will be flow also downwards from this direction. Both are added to this point, and from the total amount will be flow through the 6 ohm resistor. So whatever the amount of current flowing through the 6 ohm resistors, which is nothing but the addition of 8 ampere current and I1 dash. So the current flowing through the 6 ohm resistor, we can write that 8 I1 dash plus I1 dash, that is 9 I1 dash. So the total current through the 6 ohm resistor is 9 I1 dash. So friends, in first case we get the value of current flowing through each and every resistor. So it is quite easy to find the value of I1 dash. So if we apply the KVL in the outer loop, so what is outer loop? Just see that this one is our outer loop. So we apply the Kirchhoff voltage law in outer loop. So the 6 ohm into the value of current which will be flow from the 6 ohm, that is 9 I1 dash. So the 6 into 9 I1 dash plus here 4 ohm and 2 ohm, both resistors are in series because current source is almost open circuited, so the no current will be flow from the this configuration. So the 4 plus 2 ohm multiply by the current flowing through the both the register, that is I1 dash. So again we go for the forward direction, so the current will flow from the again to the source side, and minus to plus means in the charging mode. So the minus 30, which is equals to 0, and the 30 minus 30 go to the right hand side, and the plus 30 we have to write over here. So all the things are done. Again we have to repeat 6 into 9 and 1 dash plus 4 and 2 ohm both are in series. So the 4 plus 2 into I1 dash minus 30 equals to 0. Minus 30 go to the right hand side. It go to plus 30. So now by simplifying all the things, we get the value of I1 dash 54 I1 dash plus 6 I1 dash, which is equals to 30, and the 60 I1 dash equals to 30. 30 divided by 60, and we get the value of I1 dash equals to 0.5 ampere. So in the first case, if we consider the 30 volt source, we get the value of I1 dash, that is 0.5 ampere. Now friends, we consider the another source, that is current source, which will be given over here. So in the second case, we consider the 3 ampere source alone, which is independent. So remaining source are set equal to 0. So remaining source is voltage source. So the voltage source is sorted over here. And we have to find the response through the 2 ohm resistor in this case. And we consider the current as a I1 double dash for this case. So current through the 6 ohm resistor is obtained using Kirchhoff current law at node A. As in the previous case, we find the value of current through 6 ohm resistor, that is addition of 8 I1 dash and I1 dash, that is 9 I1 dash. So the current from the 6 ohm resistor we have to find over here, that is 9 I1 dash. Now friends, what about the current flowing from 4 ohm resistor? In the previous case, 3 ampere source is open, so we can directly see that the 4 ohm and 2 ohm are in series. But in this case, both are not in series because one parallel source of 3 ampere is also given. So we must find the value of current flowing from 4 ohm resistor. We have to get the value of current from 6 ohm resistor. We have the value of current from 2 ohm resistor, but we not have the value of current from 4 ohm resistor. So we have to find the value of current flowing through the 4 ohm resistor. So how we get the value of current from 4 ohm resistor? So consider the node B. So total amount of current entering from 6 ohm is divided into 3 parts. One part is go on to the 3 ampere, one part it go on to the 8 I1 dash, and remaining current is flowing from the 4 ohm resistor. So the total amount of current which entering by the 6 ohm resistor, that is 9 I1 dash. So the total current is 9 I1 dash. Apart from 8 I1 dash is go on to downward side. So we have to destruct the value minus I1 dash from the total, and whatever the amount of current flowing through the upward loop, that is 3 ampere, which will be also deducted from the 9 I1 double dash. So the current flowing through the 4 ohm resistor using Kirchhoff current law at node B is, or we can say the current flowing through the 4 ohm resistor will be 9 I1 double dash minus 8 I1 double dash minus 3. By simplifying all the things, we get the value of current flowing through the 4 ohm resistor, that is I1 double dash minus 3 ampere. So in this case, friends, we discuss about the KVL equation and we get the value of I1 double dash. So by applying the KVL in the outer loop, so we have to apply the KVL in the outer loop. So we get the value of 6 into the 9 I1 double dash plus 4 into I1 double dash minus 3 plus 2 into I1 double dash, which is equals to 0 because no other source is given, so equal to 0. So by simplifying all the things, we get the value of I1 double dash 54 I1 double dash plus 4 I1 double dash minus 12 plus 2 I1 double dash, which is equals to 0. 54 I1 double dash plus 4 I1 double dash minus 12 plus 2 I1 double dash, which is equals to 0. So the I1 double dash will be 0.2 ampere. So friends, in both the cases we get the value of current flowing through 2 ohm resistor by considering first voltage source and second current source, and the response are I1 dash and I1 double dash simultaneously. So by applying the superposition theorem, now we get the value of total current I flowing from the existing resistor, that is 2 ohm. So by applying superposition theorem, I equals to I1 dash plus I1 double dash, which is equals to 0.5 plus 0.2, which is equal to 0.7 ampere. So this is our final answer, and we get the I equals to 0.7 ampere for this example solution. So friends, in this case we find the total current I, that is equals to 0.7 ampere by superposition theorem. Again we recall the whole example, that is initially we consider the voltage source which is must be independent, and the remaining sources are open or short as per the condition. In second case, the current source is considered and voltage source is short circuited, and we have to evaluate the value of I1 double dash, but we does not consider the dependent source, we have to just make in the calculation. So after onwards we get the value of I1 dash and I1 double dash, and by superposition theorem we get the value of I, that is equals to 0.7 ampere. So friends, this is all about the superposition theorem. You get the exact equal to 7 marks if this question is asked, or if this type of question is asked in your GTU examination. Now one another example with different configuration we discuss. So friends, here one circuit is given. The question is that determine the value of I1 using superposition theorem in network of following figure. This question is asked in GTU January 2013 for the 7 marks. So the diagram, see that here the 30 volt source is given, 3 ampere source is given, and 8 ampere source is given. So total 3 sources are given and 3 sources are independent. So 3 cases we have to develop for the I1 dash, I1 double dash and I1 triple dash for all the sources. Here there is no independent, here there is no dependent source, all are independent source. So consider the step 1, contribution of 30 volt to I1. Initially we consider the 30 volt source alone, and we have to find out the value of I1 dash. So in this case we just consider the I1 dash, and the value of resistor is, that is 2 ohm. So both the current sources are short circuited as per the superposition theorem statement. So the 8 ampere and 3 ampere sources are sorted over here, open circuited over here, and we have to find the value of I1 dash. So the I1 dash equals to simple V upon R, because all the resistors are in series. So we can just apply the Ohm's law. So the I1 dash equals to V upon R. So the 30 upon 6 plus 4 plus 2, and we get the value of I1 dash, that is 2.5 ampere. So first case is very easy, first step is very easy, and now we further go for the next step, that is step number 2. Now friends, we consider the contribution of 3 ampere source to I1 by replacing the voltage source short circuited and current source is open circuited. So 3 ampere is now, keep in mind, other sources are set to 0 value. So the voltage source is shorted, current source is open circuited. So figure will be seen like this, and if we simplify this figure, so the 3 ampere source is in parallel with 4 ohm. So the 3 ampere source is in parallel with 4 ohm, we can draw like this, and 6 ohm and 2 ohm, both the resistors are in series if we consider this phenomena. So the 6 ohm and 2 ohm is in series. So our target is to find the value of current I1 double dash which is flowing through the 2 ohm resistor. So 3 ampere current is divided into this direction into this direction. We have the solution for this phenomena. So by current divider rule, we apply the current divider rule in this circuit. So we can easily calculate the current flowing through the this branch, and the current through the this branch is nothing but the I1 double dash. So the by current divider rule, I1 double dash equals to the total current I1 multiplied by the current flowing through the parallel branch, that is R1, the value of parallel branch, that is R1, divided by the total resistance, that is R1 plus R2, which is parallel combination with R1. Again friend, I will be repeat the current divider rule. I1 double dash equals to total current I1 multiplied by the parallel resistor with parallel with the actual source, that is 3 ampere, which is 4 ohm over here, that is 4 we have to write over here, divided by R1 plus parallel combination with R1, that is 6 plus 2. So the 3 ampere multiplied by 4 ohm divided by 4 plus combination of 6 plus 2, that is nothing but the R2. So friends, we get the value of I1 double dash by applying current divider rule. So what is the value of I1 double dash? The value of I1 double dash is 14 ampere. 1 ampere, sorry. I1 double dash equals to 1 ampere. So by applying the current divider rule, we get the value of I1 double dash, that is 1 ampere. So finally we get the step number 3. We find the contribution of 8 ampere to I1 by voltage source short circuited and current source is open circuited. We consider 8 ampere current source and we have to find out the contribution to I1 triple dash. In this phenomena, we consider the current as a I1 triple dash, which is flow from the 2 ohm resistor. Voltage source is short circuited, current source is open circuited, and we find the value of I1 double dash by applying current divider rule again. So we have to find out the value of I1 triple dash. So by current divider rule, due to the opposite direction, the direction of current is negative, so the minus 8 ampere we have to taken. The current is flowing through the downward side and it will be flow from the this direction, so the direction is taken as a negative. So we have to find the value of I1 triple dash, that is equals to the current, that is minus 8 multiply by the resistor which is parallel with current source, which is 6 ohm, which will be considered as a R1. So the 6 will be on the numerator. So in denominator, 6 plus parallel combination of 4 plus 2 ohm, that is 6 ohm. So by simplify, we get the value of I1 triple dash, that is minus 4 ampere. So we get the value of current I1 triple dash, that is equals to minus 4 ampere contributed by 8 ampere source alone. So friends, in all three cases we find the value of current flowing from the 2 ohm resistor, that is. So by applying superposition theorem, we get the value of I1, that is equals to I1 dash plus I1 double dash plus I1 triple dash. So correspondingly we have to find the already find the values, so put it into the in this equation, that is 2.5 ampere plus 1 minus 4. So total current that is I1 we get that is minus 0.5 ampere. So this is our final answer of this example. So friends, by applying superposition theorem, we get the value of I1 using three different independent sources acting separately. We get the value of I1 equals to minus 0.5 ampere. So friends, in next video, we discuss about more two examples of this superposition theorem. In next video, we will discuss about the two more examples. So by studying that total four example, we clearly see about the actual working of superposition theorem of different configuration. Thank you.